Hello everyone, welcome to another exciting math problem involving equations and their roots. This question is a modification of 2023 AIME II, problem number 8. Here is the problem. Suppose omega to the power of 7 is 1, where omega is not equal to 1. Find the product from k equals 0 to 6 of omega to the power of 3k plus omega to the power of k plus 1. Before I uncover the solution, I encourage you to pause the video, grab your pen and paper and give it your best shot. When you are ready, feel free to share answers in the comments. Later, we'll explore the solution together. Let's get started. There are various ways to tackle this problem, and in this video, we will provide a beginner-friendly approach. First, we shall define the general term in this product as pk, which equals to omega to the power of 3k plus omega k plus 1. While it's clear that p0 is omega to the power 0 plus omega to the power 0 plus 1, which simplifies to 3, we're still uncertain about the values of the other pk. For now, let's list p1 through p6 as shown. Next, based on the condition omega to the power 7 is 1 and omega is not equal to 1, we know that omega to the power 7 minus 1 equals 0. Factorize it, give us omega minus 1 times omega to the power 6 plus omega to the power 5 plus omega to the power 4 plus omega to the power 3 plus omega to the power 2 plus omega plus 1. Since omega is not equal to 1, we conclude that the sum of omega to the power k from k equals to 0 to 6 is equal to 0. Now, let's group the first and the last term of the other pk's values. For instance, when we consider p1 times p6, it gives us omega to the power 3 plus omega plus 1 times omega to the power of 18 plus omega to the power of 6 plus 1. Note that omega to the power 7 is 1 implies that omega to the power of 18 is omega to the power 4. So we can substitute that. Expanding it carefully, we obtain the following. Again, omega to the power 7 equals 1 implies that omega to the power of 9 equals 2 omega squared. So we change it as well. You'll notice that we now have the terms from omega to the power 6, omega to the power 5, all the way to omega and 1, which sum up to 0. So the product of p1, p6 is 2. Similarly, when we consider p2 times p5, it gives us omega to the power 6 plus omega squared plus 1 times omega to the power 15 plus omega to the power 5 plus 1. Note that omega to the power 7 equals 1 implies that omega to the power of 15 equals omega. So we substitute that. After expanding it carefully, we obtain the following. Once again, omega to the power 7 equals 1 implies that omega to the power 11 equals omega to the power 4. So we make the change. You'll notice that we now have all the terms from omega to the power 6, omega to the power 5, omega to the power 4, and wait, we don't have omega to the power 3. Not to worry, it was a mistake just now. Actually, this term should be omega to the power 3. So again, we have all the terms from omega 6 all the way to 1, which sum up to 0. So the product of p2 and p5 is also 2. Now I leave it as an exercise for you to verify that p3 times p4 is also 2. With this, the desired product is 3 times 2 times 2 times 2, which equals to 24. While we have successfully solved the problem, it's always beneficial to practice what you have learned. Using a similar method as shown just now, I believe you can solve the following question. Feel free to give it a try and share your answer in the comments. You can also find the solution link in the top right corner. That concludes today's lesson. I hope you enjoyed the video and stay tuned for more exciting math challenge in the future. Until next time, take care and bye-bye.